Are we good now? Okay, cool. So let's get started. The title of this talk is Unveiling the Magic of Fine-Grained Reactivity in OWL2. A few words about myself. I'm Sam. I gave a talk yesterday about comparing OWL and React. I'm not sure if anyone was there for that one. I'm a software engineer at Odoo since 2019, and since 2020 I've been a part of the JavaScript framework team. As part of that work in the JavaScript framework team, since 2021, I've been one of the core contributors and maintainers of the OWL UI library. And this talk is about the reactivity system in this library. So maybe before we start, I think it's a good idea to have a quick overview of what reactivity in OWL2 consists of. So this is a pretty simple example of an OWL component, and it uses this magic function that we call a hook in OWL called useState, and useState creates reactive objects that are tied to a specific component. So this object is reactive in the sense that any change to the object that's returned by useState will cause the component to re-render and update the UI so that the end user can see the latest state reflected in what they see. And it's also fine-grained in the sense that the component will only get re-rendered if a piece of the state that it observes has changed. But in this particular example, you can see that in the state we have two fields. One is called value and the other is called unused. And if you look at the template at the top of the file, you can see that only one of these values is read inside of the template, and it's state.value. And so that means that when we click on the first button and change the value of this specific field, the component will re-render. But if we click on the second button that changes the value of unused, the component doesn't get re-rendered. And so the reactivity system is fine-grained in that sense. It means that we only re-render for the pieces of the state that we care about in this specific component. The reactivity system is also deep, so it means that if you have objects within objects and you go read fields that are deep within nested objects, it behaves just as you would expect. So the components will correctly re-render. In this case, it's reading the primary color inside the sub-object background color that's declared in the state. But if we change the secondary color, for example, it won't re-render. So it works just as you would expect, and also there's not really any limit to how deeply nested the state objects can get, and we'll get into how this works later in this talk. The reactivity system also allows re-observing state objects. The way that this works is that sometimes you have a state object that contains many things, but many components want to observe specific pieces of that state, and so in order to render the right component, it's possible to re-observe reactive objects that come from another component in one that you're writing right now. And this is done automatically for props. So that means that in this case, you can see that we have this root component that has a subcomponent. The subcomponent is declared at the top just because it needs to be available in scope to be a subcomponent. And you can see that the subcomponent in its template is going to go read as earlier, the primary color in the theme. And the root component doesn't really care about the primary color, but it will change it. And so when we change the primary color, the top level component doesn't render at all, even though maybe it's a more complicated component. And so that means that the renders are really optimized to only change the parts of the UI that need to change. This can also be done explicitly otherwise. So if you receive some reactive object through some other means than the props, for example, if you store a reactive object in the environment, you can make it tied to the component that you're currently writing by calling useState in the setup of that component. And so, as I was saying, this avoids us from rendering the wrong component, and it also means that the components that need to render will render all the time, even if their parents don't re-render. And what this allows us to do is do shallow rendering. So that means that when a component renders, besides the first render where we have to render the entire tree, when we have some state update that needs to render some component, it doesn't need to re-render all of its children. And so we only re-render the children of a component if the props of those children have changed. And as I was saying, that means that we can have much more efficient rendering. So in Odoo, we have this thing called the UI service that holds some piece of state that determines if we are on a small screen or a large screen, for example, a mobile device. And like if I take the example of a nav bar, on a desktop, you just want the nav bar at the top that contains all of the menu elements, but on mobile, you don't want to render the same things. You want probably something like a burger menu. And so that means that this specific component, like the nav bar, it wants to render differently, but maybe you also have another component in a completely different part of the UI that also cares about rendering differently on mobile because the UX is not the same. And if for some reason you are on a tablet in portrait mode and at some point you decide, well, I want to put it in landscape mode, the value of, well, is this a small UI or not will change in this shared reactive object, but only the components that render differently on mobile and on desktop will re-render. And so you get these really, really efficient partial updates of the UI. The last thing that I want to talk about is the reactive function. It's a function that's exported by OWL. It's the primitive on top of which all of the reactivity system is built, and that includes useState. So useState is just some function that calls reactive and ties it to the current component. It can be used to create reactive objects even outside of components, so that's something that I haven't talked about yet, but reactive objects are not really tied to the component system inside of OWL. And in fact, it's even possible to use it completely outside of OWL. I've written a prototype to use the reactivity system that we have in OWL within React, and with the same kind of efficient, granular updates of the UI, and it works just fantastically. And so creating objects, like reactive objects outside of component, it allows us to share state between components that aren't parent and child. And this comes back to the example that I was giving earlier with the UI stuff, where we have this sort of shared reactive object that holds whether a state value that determines whether or not we are on a mobile device. And many components that aren't direct parent and child can just get access to this state value and update individually without having to somehow lift the state in some parent component and then just drill down this state through the entire tree, which would cause updates to need to also traverse the entire tree before it would work. The last thing is that creating reactive objects outside of component makes creating stores trivial. This is something that's not the case in other systems like React, where if you want to store, you kind of have to use a third-party library. The reactive object theme that you can see here, it's just some variable at the top level of a module, but it's actually a store, and it just works. You just have to call useState on it, and this also means we don't need a separate useStore hook. You just call useState, and you're subscribed to the bits of the store that you care about without having to write stuff like state selectors like you would have to do in Redux or something like that. All right. So the title of this talk was Unveiling the Magic of Fine-Grained Reactivity, and so now I've kind of discussed what reactivity is, how it's fine-grained, but I haven't really unveiled anything. And so in this part of the talk, we're going to talk about how this actually works. And the main piece of the puzzle to understand how this works is proxy. Proxy is this sort of magic class that was introduced in ECMAScript 6, so around 2015. It's not really brand new anymore. And so now we can use it extensively, and it's very well supported. It's a type of exotic object that kind of acts as an intermediary between an object and whatever other code wants to interact with that object, and it can intercept almost in any interaction that you would have with that object. And that includes stuff like reading properties, writing properties, deleting properties, and many, many more. So let's talk a little bit about the reactivity lifecycle. When we intercept a read operation, what we're going to do is we're going to mark the property that's being read as tracked. And that means that the component, for example, cares about that property. It read this property during its rendering, so the output of its rendering depends on that property, and so it needs to subscribe to that property specifically. And then we get the original value on the underlying object, and this is what allows us to have deep reactivity. If it's an object, we're also going to wrap it in another layer of proxy. And so that means that as you keep going down nested objects, you get a proxy and then another proxy and then another proxy, and so we can track deeply which properties the component cares about. And then we just return the wrapped value. And so this is for the read operation, the subscribing part, and now we need to care about, well, what happens when one of these properties change. And so the lifecycle for write operations is, first of all, we are going to compare whether the new value that you're writing is different from the previous value that was already in the object or not. And if it's the same, we do nothing. There's no reason to re-render components when you just assign the same value over and over onto a reactive object. Then, and this is important, and I'll get to why, we mark the property as not tracked before we notify the components and re-render them. And the reason that we untrack these properties before notifying the components is that we don't want to track properties that don't matter anymore. And the thing is, when we notify the components and re-render them, the component, as it re-renders, it's going to read again all of the properties that it cares about. And so they're going to end up tracked again. And a good example of this is conditional rendering. So I was saying earlier stuff about the navbar, right? When you're in desktop mode, you want to have all of the menu items in the navbar. But if you're in mobile mode, you just have this burger menu. And so let's say that you have a user that's on a tablet in landscape mode. We render the navbar, so they want to subscribe to all of the menu items. And then they switch over to portrait mode, and now they have this burger menu, and so they don't really care about all the individual properties. They only care about the burger menu. And so we don't want that if we add a new menu item for whatever reason, that this navbar re-renders. It doesn't matter. It's rendering a burger menu either way. And so what will happen in this flow is that when we switch the navbar to portrait mode and it switches to rendering the burger menu, this rendering that causes the burger menu to be rendered will untrack all of the menu items, and because we're not going to read them again during this mobile mode rendering, we won't be subscribed to the menu items, and that means that if we add a new menu item in the state, well, the component won't re-render because it doesn't need to, and it's aware of that fact. Right, and so that's the point. It avoids renders due to outdated tracking, and this happens all the time. There's a few limitations with the reactivity system. The first one is that it doesn't support primitives. So stuff like numbers, strings, booleans. We have some plans to maybe, at some point, introduce a signal system, stuff like Solid does. I'm not sure if people have heard of Solid.js. It's actually not very difficult to implement on top of the current reactivity system because it kind of works like signals already. The thing is, we kind of don't want to fracture the ecosystem of how people use the reactivity system, and so we're still not sure if we want to allow this different way to do the same thing. And if we did, then we'd have to choose which one we encourage people to use first and foremost. But we've been thinking about it, so maybe, like if you care deeply about having reactive primitives, just shoot us an issue on the OWL repository, and maybe we'll bump this in our list of priorities. The other thing that it doesn't support is private class fields. And I've written that this is a hard limit of proxy. Technically, you can have proxies of objects that have private class fields, but that means that you need to do some special proxying for object methods, and the methods cannot be invoked with the reactive object as their this within the method. And it means that if you read anything inside of a method, it couldn't be tracked. And so while you can have proxies around objects that have private class fields, in the case of reactivity, it just doesn't work. But the thing is, we're pretty sure that this is a bad idea in Odoo anyway, and we actually have a linting rule on our runbot that prevents Odoo developers from introducing these private properties, because this limits how much internal classes can be extended, both by our own extra modules and also by partners. And so since extensibility is part of the core identity of Odoo, we don't want this anyway. All right, so it seems like I'm a little short on time. I guess I'll be taking questions. I've opened a collaborative text document on which you can post your questions, and I'll be taking a look at them now.
Don't have so much questions, so do not hesitate to ask questions and benefit from Samuel's expertise. If we don't have any question, I have one question for you. Are you enjoying this Odoo experience edition so far?
I mean, it's been pretty nice meeting all of the members of the community. It's a great time, and lots of people have told us great things about the work that we've done in the past year, so it's been very rewarding.
So, congratulations for this new version, and I wish you all a great Odoo Experience edition.
Thank you.